So, good afternoon to all of you. Voice is audible. So, good afternoon to all of you. Okay, fine. So, in last class, we have seen this topic friction, and we already understood what do you mean by friction, and we also have solved some types of the numericals related to this friction chapter. So, this is the overview, and we also have discussed the laws of friction, laws of static friction. As far as the mechanics topic is concerned, in your chapter, static friction chapter is there. So basically, we are dealing with the static. Kinematic friction chapter is not there in mechanics part, so we will deal in later on. So after that, we have taken some type of cases. So first case we have discussed equilibrium of a body on a rough horizontal plane. So then we solve this numerical, and after that later on we have solved this example 2, and there is two kind of forces are acting. We need to find out the weight of the body and the coefficient of the static friction. So this problem I have given you the assignment. So today we are going to solve this problem. So it is mentioned in this two blocks of A and B having weight 1 kilonewton and 2 kilonewton respectively are in equilibrium. It is already mentioned these blocks are in equilibrium position. So here we need to find out what is the total force acting on this one. How much force? What is the total force? What is the total force acting on this block? And the coefficient of friction, I think, just let me check. The coefficient of friction, is how much it is given. Just need to just hold on. Yes, it is given mention point. So here it is, you have to find out, find if the coefficient of friction between the blocks, two blocks as well as B, the coefficient of friction between the two blocks as well as the block B and the floor, and the block and B, this is the floor, and this part is floor, that is given you as 0.3. So here you need to find out the P value. You need to find out the magnitude of P required to move the block B. It is the case of static equilibrium position. How you will find out? Because it is already mentioned in this problem, it is in equilibrium condition, and it is about to move, but it is not actually moving. It is in the verge of movement. So we need to draw the free body diagram of this one. So first of all, this is the external force acting on this block B. So first the free body diagram of block B is this one. So when you are drawing the free body diagram of the block B, you just remove block A, and whatever the forces are acting on block B, you just finding out. So this is the external force P acting on the block B. When external force act on the block B, there is friction will develop in between the block and this floor. In between block and this floor, that is F2. And in between this block A and block B, because block A will try to stay, okay, an external force acting in this opposite direction, so there is a opposite friction force will also act, that is F1, in between block A and block B, that is friction 1. And this is the tension T. This tension T will develop because this string is attached to one, this is a fixed I think a fixed support. There will be a fixed support will be there. This string is attached to the block A, so there will be a friction, a tension will develop at an angle of 30 degree. This is not actually, this is block A. We are drawing the block B, sorry. So just I need to erase this one. So this is not required at all. This is, we are drawing the free body diagram of the block A. So now whatever the then one reaction force, because the block B is in contact with the floor, so there will be a reaction force R2 is developed, okay, because the contact point at this point. And finally this on this block B, the weight of the block B, that is 2 kilonewton, plus the contact force in between this block A and block B, that is R1. Okay, R1 is the reaction force. Similarly, if you draw the free body diagram of the block A, now this is the free body diagram of the block A. So in block A, to maintain the body in equilibrium, the friction force is acting on the block B in opposite direction. To maintain that one, the friction force will develop in opposite direction, because net force will be balanced. Okay, otherwise the body will be disturbed. So this is the friction force, and the weight of the 1 kilonewton is acting downward, that is 1 kilonewton. And at this contact point, the reaction force will develop. At this contact point, this is block B and block A contact point, so there is reaction force R1 will develop. And this is the tension string, T the tension in the string, that is at angle 30 degree. Okay, so these are the free body diagram of the block B and block A. So if you write down the equilibrium equation, so because we are dealing with static condition, so how much equation I already told, the summation of net force in x direction will be equal to 0. Second equation is summation of net force in y direction will be equal to 0. This static equilibrium equation you need to use throughout your mechanics chapter. So here in the case of block B, if you use the static equilibrium equation, summation of net force in x direction will be equal to 0. So what are the forces? You can identify one reference axis. This is my positive x, and this is my positive y axis. Okay, positive x and positive y axis. So net force in that x direction. So this is F1 friction 1 plus F2, okay, minus P will be equal to 0. So this P will be equal to F1 plus F2. This is the friction force. So this is equation number 1. So if we can find out F1 and F2, then our almost job is finished. So F1 we can find out from this block A free body diagram. F2 we can find out from the block B free body diagram. So what is this F2? F2, this is F2 will be equal to mu into this R2, we know, mu into this R2. So now if you use second static equilibrium equation, the net force in y direction will be equal to 0. So what are the forces acting in this case? In this case, what are the forces acting in free body diagram? So this R2 is acting in upward direction. We are talking about the block B, okay, and the what is the force acting? 2 kilonewton plus R1, okay, so 2 kilonewton plus R1. So first of all, we need to find out this R1, okay. So F2 will be equal to mu into R2. So this is R2. Okay. So R2 minus 2 kilonewton plus this is R1 will be equal to 0. Okay, will be equal to 0. No other forces acting. So this is R2 will be equal to 2 plus this is R1. So mu is given you as 0.3. Mu is how much? Mu is given you as 0. That is 3. 0.3 is given to us. So mu, we need to find out what? Now F2, if you find out, this F2 will be equal to mu into this is 2 plus R1. Or that is 0.3 into 2 plus R1. So now our job, we can have to find out this R1 value. Okay, if we can find out this R1 value, then almost our job is finished. So how to find out that R1 value? We can find out from the free body diagram of this block A, the block A. Now if you look the block A, okay, now let me, okay, now this is the block A, this is block B I just talked about. Okay, this is block B. So block A, if you use the static equilibrium equation, net force in x direction will be equal to 0. So net force in x direction will be equal to 0 if you see this block A diagram. So whatever the force are acting, this F1 is acting, and this, if you take the component of the tensile force, that is this is T cos 30 degree. So is it again good? So is it clear now? Okay. So if you see, so is it okay? So let me solve this one very carefully. So if you take the resolution of this one, that is T cos 30 degree, and in this direction that will be, this is T sine 30 degree. Cos 30 degree, and in this direction that T sine 30 degree. Okay. So now if I will write net force in x direction will be equal to 0. So what are the forces are acting? That is T cos 30 minus this is F1. Okay, that is T cos 30 degree minus this F1 will be equal to 0. Okay, so this F1 will be equal to T cos 30 degree. Okay, and this F1 I can write, this is mu into R1 will be equal to T cos 30 degree, and here this mu is 0.3 into this is R1 will be equal to T cos 30 degree. So R1 will be equal to T cos 30 divided by this is 0.3. So this is R1 value. So here again you need to find out the T, what is the tension in the string. So again if you write down in block A, net force in y direction will be equal to 0. So net force in y direction will be equal to 0 means what are the forces acting? This is T sine 30 plus R1 minus 1 kilonewton. Okay, that is T sine 30 degree plus this is R1 minus 1 kilonewton will be equal to 0. So from this equation I can put this is T sine 30, okay, T sine 30 degree, or we can talk about R1, that is T cos 30 degree. We just put this value, here, divided by this is 0.3 minus 1 will be equal to 0. So if you solve this one, you can find out the tension developed in the string. If I can solve, you can find out the tension developed in the string. And if you solve this R1, after getting a tension in the string, you solve it, then you find out R1. R1 you find out from this. After finding R1, you can find out F1. F1 will be equal to mu into R1. So F1 you can find out. After finding out the F1, you can also find out this F2. So this is 0.32. So F2 also you can find out. F2 also you can find out. So finally this equation we know this P will be equal to F1 plus F2. That is net force will be equal to F1 friction force in F2. So F1 you know F2. So P you can find out. So from this equation, you just find out the tensor developed in the string. T value we just find out. And after finding out the T value, then you find out this R reaction force, then you find out the friction developed mu into R1, then F2 you find out, then P. There is many other way also you can solve this problem, but this is the way I has given to you. So this is the solution I have given, so you can tell later. Now today we'll talk about the equilibrium of a body on a rough inclined plane subjected to a force acting on inclined plane. So this is the case of inclined plane. When there is a body which is sliding off or down in an inclined plane, how will solve? Now suppose this is two cases will be there in this problem. There will be two cases is there in this problem. So first case is the body at the point of sliding downwards. Another case will be the body at the point of sliding upwards. There will be two cases. So in two cases, suppose I am talking about the first case. This is the first case. Suppose when the body is sliding upward, mean what is the maximum value of the P2 we can take? What is the maximum value of the P2? So if you take the free body diagram of this one, so this is the free body, this P2 is acting upward. We need to find out what is the maximum value of P2. What is the maximum value of P2 such that the body will remain in equilibrium, because the weight of the body is here is more. So how much maximum the P2 will act on this body such that the body will remain in equilibrium. It will not move, but at the verge of motion. Okay, limiting value of P2 we are finding out. So this is the reaction force between the block and floor, and this is the friction F2 is developed because the body is moving in this direction. So the friction will move in opposite direction. And this is the angle in between horizontal and this floor. So if this is alpha, then this angle will also alpha. Now suppose this is my reference axis. This inclined plane. This is my positive x and this is my positive y. Now if you do the resolution of this component, because all forces are in this reference axis, so this will my W cos alpha, and here in this direction, this is my W sin alpha. Okay, now all the forces are in component. Same you can use first net force in x direction will be equal to 0. So net force in x direction will be equal to 0. Just I am deriving the generalized equation so that it will have an idea, that you can get one idea, so that remaining problem you can solve it. So what are the forces acting? So this is my positive, this is P2 minus this is W sin alpha W sin alpha minus this F2 friction 2 will be equal to 0. So here P2 we can find out, this is W sin alpha plus this is F2, and this is W sin alpha plus F2 we can write this is mu into this is R2. Okay, this is my P2. So this is R2. R2 need to find out. So R2 we can find out another equilibrium equation, that is net force in y direction will be equal to 0. So if you write down net force in y direction will be 0, so minus this is W alpha. Any other forces acting? No. So will be equal to 0. So simply R2 will be how much? This is W cos alpha. This is equation. Now put equation 2 in equation 1. So if you put equation 2 in equation 1, so this P2 will be equal to, this is W sin alpha plus mu R2 is W cos alpha. Okay. So again I can write it down. This is W sin alpha plus mu, I can write out what is mu will be equal to 10 phi. Phi is the angle of reforce. So this can I write out, this is 10 phi into this is W cos alpha. So I can take W common. So this is sin alpha plus this is sin 10 theta is what? Sin phi by cos phi. So this is 10 phi into this is cos alpha. Okay. So now if you multiply this cos phi in every term, this is P2 into this is cos phi. So this will be become W into sin alpha into cos phi plus this is sin phi, become sin phi into cos alpha, because sin phi by cos phi will cancel, sin phi into cos phi. So this is the formula, sin A into cos p plus cos A into sin A into cos p plus cos A into sin b. Okay, sin A plus sin A into cos b plus sin b into cos A. So what is the formula? The formula is what? This is sin A plus b. So this will be called W into sin alpha plus phi. Again I am rewriting this one here. And I am rewriting this one. So this equation become P2 will be equal to W into sin alpha plus phi divided by this is cos phi. So this is one generalized formula you can also refer. Otherwise you can solve by your way, that is not a big thing. So this is the thing. So now this is one case. When the body at the point of slide downwards, when the body is sliding downwards, the body is now is moving in this direction. So obviously the friction will act in opposite direction, and this P1 is acting. Now what is the minimum value of P1? Now here we are finding out the it will slide down continuously. So here we are finding out this one. Earlier actually we find out this is the maximum value. P2 max how much? This is the what is the P minimum. This is P minimum, how much we have find. What is the minimum value? Okay, P1 minimum. Same you can take this one as resolution. This is W cos alpha, and then just the friction changes the sign, otherwise whole thing is same. This is W sine alpha. Okay, w sine alpha. And other things are as it is, and this is my positive x, positive y, this is my positive x, and this is my positive y axis. So same thing, I will use summation of f of x will be equal to 0. You write down yourself, it will be practice for you. What are the forces? This is P1. Now friction will act in this direction, this is F1. Just this will be minus W sine alpha will be equal to 0. So this P1 will be equal to W sine alpha minus F1 is mu into this R1. Okay. So this is my equation 1. R1 we need to find out. R1 we need to find out. So that we will get from the next equation. So net force in y direction will be equal to 0. So what are the forces in y direction? That is R1 minus this is W cos alpha will be equal to 0. So this R1 will be equal to this is W cos alpha. So this is equation 2. Now put this equation 1 equation 2 in equation 1, that is P1 will be equal to W sine alpha minus mu into W cos alpha. And mu, and you can solve this is take, you can W you can take common, this is sine alpha minus tan phi into cos alpha. So this is the P1, and now other thing will remain same. Okay, so you solve it yourself, and this is the assignment for you. Now you go to the description part and you have a attendance link, you just click that one and enjoy this one. So thank you for today class. Fill the attendance link given in the YouTube description today. So thank you. Tomorrow I will take class.